So the parallelogram law states that if two forces acting at a point are represented in magnitude and direction by the two adjacent sides of the parallelogram, then their resultant is represented in magnitude and direction by the diagonal of the parallelogram passing through the point. Here, two forces F1 and F2 are acting at an angle of theta at a point O. So here F1 and F2 are said to be concurrent forces and their angle between them is theta. So the resultant of this two forces can be found out by the equation R equals root of F1 square plus F2 square plus 2 F1 F2 cos theta, and the direction of the resultant alpha can be found out by using alpha equal to tan inverse of F2 sin theta divided by F1 plus F2 cos theta. Now we can see how these equations are obtained. Now F1 and F2 are two forces acting at an angle of theta. F1 is equal to OA and F2 is equal to OB. Now we construct a parallelogram based on this sides F1 and F2. So draw a line parallel to OA and draw a line parallel to OB such that you will be getting a parallelogram with the intersection point C, and now OC gets the resultant of the parallelogram. Now here OA equal to BC, that is equal to F1, and OB is equal to AC, that is equal to F2, and angle BOA equal to angle CAD, that is theta. So now taking the triangle ACD with an included angle of theta, so we can write sin theta equals CD by AC and cos theta equals AD by AC, so that we will be getting CD is equal to F2 sin theta and AD is equal to F2 cos theta. Now taking the right angle triangle OCD, we can write OC square equals OD square plus CD square. So OD is equal to OA plus AD. So we can write OC squared equals OA plus AD the whole square plus CD the square. Now R square equals OA equal to F1 and AD is equal to F2 cos theta and CD is equal to F2 sin theta. Now applying all these values in the equation, we will be getting resultant equal to root of F1 square plus F2 square plus 2 F1 F2 cos theta. Now coming to the direction of the resultant, we will be taking the angle, right angle triangle, angle OCD. In that tan alpha we can write as height by distance, that is CD by OD. Now alpha becomes tan inverse of CD by OD. So now CD we can substitute, CD equals F2 sin theta and OD equals OA plus AD. So OA here equals F1 and AD equal to F2 sin theta. On applying these values, we will be getting the direction of the resultant alpha as tan inverse of F2 sin theta divided by F1 plus F2 cos theta. So here we can see the simple problem based on the parallelogram law of forces. Two forces of magnitude 100 Newton and 50 Newton are acting at a point. If the angle between the two forces are 60 degree, determine the magnitude and direction of the resultant force. Here we want to find out magnitude of the resultant R and direction of the resultant alpha. So the given data is F1 equal to 100 Newton and F2 equal to 50 Newton and the included angle between them is 60 degree, that is theta. This problem can be solved by using two methods. One is analytical method, another one is graphical method. We will be seeing one by one. In the analytical method, we will be using the equations R equal to F1 root of F1 square plus F2 square plus 2 F1 F2 cos theta and alpha equals tan inverse of F2 sin theta divided by F1 plus F2 cos theta. So we know the values F1 is 100 and F2 is equal to 50 and theta is equal to 60 degree. We will be getting resultant as 132.28 Newton and the direction of resultant alpha equals 19.1 degrees. This problem can be proceeded also by the graphical method. So here F1 is 100 Newton and F2 equal to 50 Newton and theta equal to 60 degrees. So F1 1 Newton we are taking it as 1 mm So for 100 Newton, we will be drawing a line, horizontal line of equal to 100 mm and representing the 100 Newton force. Similarly, we will be drawing 50 mm line representing the F2 force, that is AC. OA is equal to 100 mm and AC is equal to 50 mm, such that the angle AC will be 60 degrees. Now we will be getting 2 points O and C. When we join that line, join the point, we will be getting the line OC. On measuring OC, we will be getting it as 132 mm. So here we reverse it. So 132 mm is equal to 132 Newton, and measure the angle COA, you will be getting alpha equal to 19 degrees. So based on the drawing accuracy, we will be getting the answer near to the analytical method. Thank you.